Congratulations on hitting the end of this chapter where we were learning about logical operators and three-way comparisons in C++20. We started out by looking at the old way to overload logical comparison operators in C++. And you had to do what we have here. For example, you could do them as member functions. It is also possible to do them as non-members. But this was really tedious because you have to put in all these operators. And this gets even crazier if you have to support implicit conversion from other fundamental types. This is going to be really a lot of code to keep track of and maintain. We saw an effort to try and simplify that using the relops namespace. All you had to do was set up the less than operator and the equals operator, and you could just include the utility header and bring in the relops namespace, and the compiler would use the built-in template functions to generate all the other operators. And with this, you could just use all the other operators and they would work without a problem. But with this, the problem with implicit conversion still remains. So this is still a problem, and C++20 has tried to solve this problem as we saw in this chapter. Okay, the main problem with the old way to do things was that you had to overload a lot of operators, and this could get really crazy if you are supporting implicit conversions. For example, here we had to do 18 overloads of our operators, and this is really crazy. We don't want to write code like this. So C++20 introduced the three-way comparison and the infrastructure around that to simplify how we do logical operators moving forward. We started out by looking at the equality operator, and that we could default it. This would do default member-wise comparison on the member variables. And if this works for you, this is a good way to really simplify things. You're going to default this operator, and the compiler is going to use it to even generate a not equals operator that you can use in your program. We moved on and saw a way we could set up a custom equality operator if the default way of doing things isn't working for us. For example, for our point class, we needed to compare points based on their length, and we saw that we could do this, and still the compiler would use our equals operator to set up a not equals operator that we could use in our program. Another important thing about this way of doing things in C++20 is that implicit conversions are going to work without really too much effort. For example, we have a constructor that takes one double parameter. This could be used in implicit conversions, and implicit conversions are going to work regardless of where we have the fundamental type. For example, we can have a literal either on the left or the right, and the compiler has the option to do a bunch of rewrites of our statement to call our operator, which is done as a member function. And this is really cool. It is going to simplify your operators a lot. We also saw that we could default the three-way comparison operator, and the compiler would use this to generate our greater than, less than, greater or equal, and less or equal operators. But we also get another bonus if we do things like this. Because this is going to do member-wise comparison, the compiler is going to say, if this guy is doing default comparison, I can also default comparison for the equals operator. So the compiler is going to give you a free equals operator that can in turn be used to give you a not equals operator. And this is really cool. This is the sweet spot of comparisons in C++20. If you need all the operators and you can afford to do member-wise comparison, you can set up just one member function, the three-way comparison operator, and the compiler is going to give you all the 6 operators. And this is super cool. We moved on and looked at a case where we have a member function which possibly doesn't implement the three-way comparison operator. If we don't have any comparison operator, be it the three-way comparison operator or the less than or equal operator, the compiler is going to see that it can't really compare the D member variables. So it is going to delete this default three-way comparison operator and throw a compiler error if you even try to use this. But if you happen to have less than and equals implemented for the integer type here, the compiler can still do its best and synthesize a three-way comparison operator that can in turn be used by our item class here. And this is really cool. But for that to work, we needed to help our compiler out and not auto-deduce the return type of our three-way comparison operator. We need to do some careful thought and think about the ordering that we want for our three-way comparison operator, and this is going to work. One thing we noticed is that this was not working on the current compiler that I am using, the GCC compiler. I have 10.2.0 and that doesn't support this feature yet, but this is going to be fixed in the future. That's my hope. But we saw that this was working both for Clang and the latest version of the compiler from Microsoft, and this was really cool. Okay, so we moved on and looked at how we can set up a custom three-way comparison operator. This was nothing complicated. The biggest decision you have to make is which kind of ordering you want to return from your three-way comparison operator. In this case, our member variables were of double type, so the ordering of these fundamental types is going to be propagated to our three-way comparison operator. That's why we return partial ordering here. Okay, next we had a chance to compare the old way of doing things to the new way of doing things. You can see that now we have to overload only 4 operators in our class, and this is a big improvement considering that we could do 18 operators to achieve the same thing. So C++20 is simplifying this a lot. We also had a chance to look at the fact that it is possible to set up our comparison operators as non-members, and this is going to allow implicit conversion from a completely unrelated type that has the ability to convert to our type here, and we had a chance to look at an example. I have to say that you won't need to do this a lot, so my advice is to always do your comparison operators in C++20 as members and give the compiler a chance to kick in and really do all kinds of the flipping to get your comparisons to work, and that's going to simplify work a lot. After that, we looked at a bunch of examples of how you could set up weak ordering and partial ordering, and hopefully that gives you a really good stronghold to work with comparison operators in C++, especially in C++20. This is really all I had to share in this chapter. I hope you found it fun and informative. We are going to stop here in this one. In the next one, we're going to start and learn about a really big feature in C++, which is inheritance. So go ahead and finish up here and meet me there.